Okay, good afternoon. If you can hear me, please hear me loud and clear, please signify. Okay, I'll be treating sets based on our discussion earlier. So, and we'll take it like kind of fast, uh, since it is not a topic that is new to any one of us here, and if it is actually new, then I'm sure you will get it as we start. So, starting from the word set, okay. I'm very sure you'd have heard of the word set before. Okay, set. So maybe set off, or we say set 2025. Okay, you hear mathematical sets, uh, and any other sets. So in short, the definition for set is collection of a well-defined object. So set is a collection of what? A well-defined object. So that is just set basically. Okay, so then we'll be moving on to the types of sets, or before that we'll look at what is set itself. Okay, set itself, we can then say anytime you are trying to write set, the set itself is written in capital letter, while its member will be written in what? In small letter, though it is conventional. Okay, so for example, I say class class 9. Okay, a member of class 9 is Ade. Okay, so the set of class 9, this is the set collection of a well-defined object. Okay, so Ade is a member of this, then you write it like this in set. Ade is an element of class 9. Okay, so this E here represents what? Element, a member of the set. Okay, then you can have something like this. A is a set of 1, 2, 3, 4, and 5. A is the set itself, while this 1, 2, 3, 4, and 5 are the elements. Is an element of set A. 2 also is an element of set A. 3 is an element of set A. 4 also is an element of set A. Okay, so all these here are elements of set A. A is the set, while these ones are the member. We call them points also. We call them members of set A. Okay, so that's the first part. Now another thing that you need to know again is that in writing sets, write sets in either roster form or write it in a set builder form. Roster form or set builder form. Description of sets. Roster or sets builder. Now for the roster form, it is a way of writing sets, whereby you list out the elements within the braces and you separate them with commas. Okay, so this one here, this approach or this way that you write out, or that you have this set on the board here, it is in roster form, because I put down the elements within braces. These are the braces, and I separated them with commas. So that's roster form. Okay, but then for set builder form, okay, this one here, you have to state a particular condition that all the elements satisfy. Okay, let me start with roster form. Let's say A, the set of letters, all letters in the word um, academy. Okay, so set A element will then be what? We have A itself, we have C. This A is just a repetition, so you don't need to write it again. We have D, we have E, M, and what? And Y. Okay, so here now I'm only writing out the element and separating them with what? Commas. Okay, now moving on. That is for roster. Just note that you don't have to repeat the letter. Then you can have let's say the set of months that are 30 days. Hmm? Let's say B set of months that have 30 exactly 30 days. Exactly 30 days. So for that one, we'll say 30 days are September, April, June, September, and what? November. Okay, so I think we have 4 months that are that have exactly 30 days. So what I did here now is that I put down this set in roster form. Now looking up or moving on to writing it in set builder form. Okay, for set builder form, you may have something like this. You have uh, you have it listed already. So let's say 1, 2, 3, 4, 5, 6, and 7. Now I need to describe these sets using set builder form. So what you just need to know here is that whenever you are to describe sets using the set builder form, you need to understand the types of numbers builder form. Remember, we have the classification of numbers. You have your real and those numbers that are not real. Okay, the complex numbers. Under the real numbers, you have the rational and you have irrational. Okay, and for this rational, under this you have your integers. That is the whole numbers, negative and what? Positive. And even under this again, we have our natural numbers. Okay, now starting with this, real numbers are generally that number that you've been coming across right from your should I say your nursery school up to your secondary school. Any number that is real, that is does not have any complex characteristic. Under the complex number, you'll be having this root of -1. That is why when you put this thing in your calculator, you have it to be math error. But in mathematics, we represent it to be what? To be I. Okay. So for the real numbers, this one actually exists. Okay, they do exist. So it is then subdivided into two. The rational number. This one is by R like this. Okay, that's real number. So whenever you see this, you should know they are talking of what? real numbers. Now, rational numbers. Rational numbers are numbers that can be expressed in fractional form, like in form of a over b. So all whole numbers can be expressed in form of what? A over b. Okay, just like you have it 2. 2 can be written as what? 2 over 1. Say 40. You can say 40 over 1. So it can be written in form of a over b. So all whole numbers are rational. Another one again that is rational is terminating decimal. Terminating decimals. So any decimal that terminates, that is stops, you can also express that in fractional form. Example 0.125. You can see it stops. So that's 125 over 1000. Then you reduce it to the simplest form. You say 25 here, 5. 25 here should be 40. 5 here 1, 5 here 8. So that's 1 over 8. Can you see we can express that in form of a over b? So that is terminating decimal. And any other decimal that terminates, that stops, okay, is regarded to be what? Irrational. Another one is recurring decimal. Decimal that reoccur, it follows a certain pattern. For example, 0.131313. Now this, now you notice that the 13 is repeating itself, is reoccurring. So this one also we can express what? In form of a over b. How do you do this? Okay, let's start with if it is 0.3333 and it continues that way. Okay, this one here, instead of it being, okay, you can as well write it as 0.3 then a dot on it, meaning the 3 reoccurs. So you then say this one here, instead of saying you have 1 digit after the decimal point, okay, saying 1 digit after decimal point and saying that will be 3 over 10, it won't be 3 over 10, it will be 3 over 9. Okay, so just say 10 minus 1. Say 10 minus 1. Okay, so you have that to be 1 over 3. So if you punch 1 over 3, you input 1 over 3 in your calculator and your device, you have 0.333 and it continues that way. Okay, so for the 0.131313 that I put the other time, so this one also continues, so you have it to be 0.13, okay, meaning the 13 repeats itself. So in this sense, to write this one in rational form, in form of a over b, that will be 13. You know, it should have been what? 13 over 100. At d being, it is a terminating decimal. But here, you say 100 minus 1, and that was 13 over 99. So 13 over 99 will give you 0.131313, and it continues that way. So you now see that a recurring decimal also can be expressed in what? In rational form. Okay, so rational numbers, whole numbers are rational, terminating decimal are rational, and recurring decimal are also what? Rational. So if the opposite of rational is irrational, so generally rational numbers is denoted by what? Q. So any number that does not have this possess this characteristic, this, it is not whole number, it is not terminating decimal, then you should know that it is irrational number. Okay, for those that are joining, thank you very much for joining. If you have any question, you can drop it in the comment section, so I'll look into it after that and I'll prepare a video for that. Okay, so riding on, I said irrational number. So if it is not rational, then it is what? Irrational. So irrational number the decimal will not terminate. They are not even whole numbers. Okay, the decimal will not terminate, and what? It will not what? Reoccur. So that's for irrational. We can have it as what? I. Then the next one is integers. Integers are positive and negative whole numbers. Okay, on your number line, I believe you would have come across that. On your number line, you have something like this. You have your 0, you have 1, you have 2, 3, 4. On the negative part, you have -1, -2, minus 3, and it continues that way. Okay, so all these whole numbers, either positive or negative, are integers. Okay, so all these are integers. So integer is denoted by z. So if it is then positive integer, you have plus representing positive integers. Okay, then if it is this, you have it to be what? Negative integer. Okay, now moving on, we have natural numbers. So natural numbers are your counting numbers. That is the number you start with basically when you are in primary. The numbers you start with basically in primary classes. Okay, so we say your natural numbers are your counting numbers starting from 1, 2, 3, 4, 5, and so on, like that. Your counting numbers. Okay, so that's natural number. Another thing that you should know again, okay, I already explained complex number. Whenever you have this I there, you should know that it is complex, it is not real. Okay, anytime you have, probably you have 3 minus 2i, you can see you have I there already. So this is a complex number, it is not real. But then either it is irrational or rational, it is still what? Real. Do you get that now? So either the decimal terminates or it does not terminate, it will reoccur or it does not reoccur. All together now, it is what? Real. Example of irrational number before I skip that. We'll talk of all sorts are irrational. All sorts, we call them radicals. They are irrational. And for transcendental number, still under irrational, we have your exponent, we have your pi. Okay, these are transcendental, though they are irrational, but they are special. Okay, so these constants here, if you input them in your calculator, you have them to continue. It will not terminate, and you will not see a pattern reoccurring. Okay, that's so therefore you cannot express them in form of a over b. The next one is pi. People get it confused when they see pi. You know, most of the time in secondary school, for the secondary school student that will be watching this video, they'll take pi, they'll tell you that take pi to be 22 over 7. Now, pi is not exactly 22 over 7. Okay, it is an assumption, it is an approximated value for us to take pi to be 22 over 7. So pi is not exactly 22 over 7. Pi is an irrational number. It is a decimal that will not terminate, it will not stop, and it will not reoccur. But this 22 over 7, if you should put it on your calculator and check for the, let's say, the first 20 values, you will notice the pattern. The pattern will reoccur. That on your own. So pi is irrational. Okay, so another thing that we want you to know again, because those are what we'll be using when we get to set itself, is that the only prime number that is even, the one we say prime numbers, prime numbers, the prime number only have how many factors? It has 2 factors, just 2 factors, 1 and itself. So all prime numbers, the only one that is even is what? Is 2. That's the only even prime numbers. So 2 is the only even prime numbers. Now for this one here, to write this in set builder form, you notice all these are natural number. Okay, so what you say is that you say A is a set of x such that x is an element of natural number. Natural number is denoted by n, I think I forgot to tell you that, denoted by n. Okay, so element or member of natural number. But then you notice that I said it the other time, the natural number continues. Okay, but here it stops at 7, so that means x is less than or equals to 7. Okay, x is less than or equals to 7, so that is where it stops. Natural number, but then it is less than or equals to 7. So this form of writing set is what we call set builder form. Set builder form. Okay, we may have another one. Let's say we have b we have 1 over 2, 2 over 3, 3 over 4, 4 over 5, 5 over 6. I will ask to write this in what? In set builder form. How do you write this? So what you do here is that you say, you should look at this very well. You notice this top here, they are all natural number from 1 to what? To 5. That's the first thing. But then you discover that this one here exceed this one, the numerator, just by 1. So we say b is a set of x such that x is equals to, or yes, such that x is equals to n over n plus 1. Okay, the n is representing the number of terms. So this one is for 1. When this one is 1, this one is 1 plus 1, which is 2. When this one is 2, that will be 2 over 2 plus 1. That will be 3. That's 2 over 3. When this one is 3, that will be 3 over 3 plus 1. And that's what? 4. That's 3 over 4. And it's continued that way. But then note that n is an element of natural number. Also, n is less than or equals to what? 5. Okay, n is less than or equals to 5. So every of the properties that you need know, it should be what? Okay, there's a question being asked. Oh, I said all prime numbers, they only have two factors, one and their self. Like if it is 2 now, 2 has 2 factors, just 1 and 2, 3, 1 and 3. Do you understand that now? But I said the only even prime number, that is the only prime number that is even is 2. The number that is even is what? Is 2. I hope you get that point now. And thank you, Ezra, for the explanation. Okay, so moving on. So this is for set builder form. So it comes in different way. You may have it also in this way. Look at, let me say C. This is set builder formation. C is a set of x such that you can have the such that also as a stroke like this, such that x x square, let's use this, x plus 3 plus 2 equals 0. Now I have to list out to write this thing in roster form. You can see it is what? A set builder form. So let me say x is an integer. Okay, x is what? A member of integer. So we then try to solve this one here. You can see that was a quadratic equation. To solve this, you say this is your sum, and the product is what? This multiplied by this, and that will be 2. So you say your two numbers that when you multiply you have this. Okay, that will be 1 and 2. Is there any number that when you multiply you have 2? No. Okay, so that's the only two numbers we have. Now check if you should add this, will you get 3? Yes, I'll get 3 when I add this. And when I multiply this, I have 2. When I add this, I'll get what? 3. So automatically, to break this one down, I'll use 1 and 2. You say x squared plus, instead of writing 3x, you break it down to be what? 1x plus 2x. 1x plus 2x give you what? 3x plus 2 equals 0. Now it's just a means of breaking this one down because it's a trinomial on the left hand side. Okay, breaking it down to be what? To be 4. So we can take it 2, 2. So taking this one, this and this, and this and this. So we factorize. What do they have in common? They have x in common. You have x left for this plus x is out, it remains 1. For this one, since we are taking this 2, you start with the sign you have here. So that's plus. What do they have in common? 2. It has x left. Note, if it is minus that you have here and you're putting minus here, that means you're factoring out minus. So anytime you're factoring out minus, it will change the sign of what you have inside. But if it is plus, you don't need to bother. So since it is plus, it remains plus. But note, if it is minus, this thing will have to what? Change. So you have this to be 1 equals 0. Now look at this term and this term. We have two terms. The two terms, they have something in common. What they have in common? X plus 1. So you say x plus 1, bringing it out. What do you have left here? When you bring out x plus 1, you have x left. Okay? When you bring out x plus 1 out, what do you have left here? Plus 2 equals 0. So that means this multiplied by this equals 0. Definitely one of them should be 0. Because is there any two numbers and when you multiply you have 0? That either of the two is not 0. No. So one of the two should be 0. So it is either x plus 1 is 0 or x plus 2 is 0. So by solving this, you say x equals minus 1, transposing this plus 1 to the other side, or subtracting 1 from both sides. Okay, this one you have x to be what? Negative 2. So that means x is negative 1 or negative 2. Now go back to this. Is this values or are these values satisfying the condition here? Yes. Integer can be negative or positive. So therefore we'll conclude that C, the element of C, they are what? Minus 1 and what? Minus 2. Another thing that I want you to know is that the order of doing this thing, of putting this thing down, is not relevant. So you can say minus 2, comma minus 1. Still the same thing. But then you arrange it, there's nothing bad regarding that. Okay, moving on. We'll then be looking at some basic facts about sets, the types of sets that we'll have. We'll look at them. I'll explain everything that you need to get. Okay, starting with the first one, I'd love to talk about the empty set first. The empty set. Okay, you already know when I say A is an element of set A. So that means among the elements or the points in A or the members of A, this small case, A is also part. Do you get that now? But then if, okay, for example, we have A to B, A, B, C, D. I can write it out that this is a member of this. But then is 1 a member of A? No. Regarding this question, 1 is not a member. So you write it like this. 1 is not a member of A. So just like you saying x is equals to 2, if x is not equals to 2, you say x is not equals to 2 by cancelling. So this also, that is what you do regarding that. Now, empty set. An empty set is a set that do not have any element. Does not have what? does not have any elements. Okay, it is also called a null set. Null set. I'll call it what? A void as well. Void set. So a set that does not have any elements. Okay, now do not call this a zero set. It is not a zero set. Okay, it is why you call it empty, null, or void. Okay, so it is denoted by just the two braces. Okay, or this way. This is what? Null set. So that you write it this way or you write it this way. Both means what? They are empty. That is it does not have any elements in it. Okay. So if a set then has at least one element, you say it is non-empty. Okay, it is not empty in that sense. Example of empty set. Let's look at this. Say A is the set of x such that x is an element of natural numbers. Now what this means, to read this thing here, you don't say 2 is less than x, you start with x. If Bolu is less than Bola, that does not mean Bola is less than Bolu. It means what? Bola is greater than Bolu. So if 2 is less than x, we have to read from here, you say what? X is greater than 2. Okay? So reading this set here, A is a set of x such that x is an element of natural numbers. X is greater than 2 but less than 3. So is there any natural number greater than 2 but less than 3? Any natural number greater than 2 but less than 3? Okay, we don't have any natural number greater than 2 but less than 3. So in that sense, we say it is what? An empty set. It does not have any element, it does not have any point, any member. I hope you understand that. That is for what? For an empty set. It may also come in this way, saying B is a set of x such that x is an element of real numbers. I told you earlier, real numbers, and x squared plus 1 equals 0. X squared plus 1 equals 0. Now for this here, okay, you look at this, x squared plus 1 equals 0. To solve for x here, bring this back to this side. I have x squared equals what? Minus 1. Okay, taking the square root of both sides, we have x to be plus or minus square root of minus 1. And I told you earlier, we watched the video from the beginning, you discover that square root of minus 1 is what? I said it is denoted by what? I, and it is what? An imaginary value. Okay, so that means we have x equals plus or minus I. So in this sense, our x is plus or minus I. But remember, the condition is x is an element of real numbers. So I told you that this is not real. Therefore, B is what? Empty. We don't have any real value. Huh? I'm sorry for the disconnection. I think I have a network issue. So you guys can join again, please. Okay. Okay, moving on. Moving on. So I was explaining the concept here. I have b equals b is a set of x such that x is an element of natural numbers. X squared equals x. So bringing out this, taking this to the other side, in factor out x, since I have x in common, so this one is now a product of two factors, which is equal to what? 0. So that means it is either this is 0 or this is 0. Okay, transposing this to this side or adding the additive inverse of this to both sides. You have minus 1 plus 1. Is this 0 plus 1? You have this one to cancel this. X equals 0 plus 1 with 1. Okay, so remember the condition here that x is what? An element of natural number. So based on what we were treating earlier, I told you that natural number start from 1, 2, 3, 4. Though there is what? Controversy on that natural number is it from 0 or from 1? But as per this, I'm using natural number to start from 1. Okay, so 1, 2, 3, 4, and so on, like that. So since 0 should not be regarded as natural number, the only element for set B will be 1. So it's a single thing set. Now, on no condition, when you have a set like this, should you assume it is an empty set? No, 0 is an element of what? Integer. So do not say this is an empty set. It is not an empty set, but what? It is a single thing. It has just one element, exactly one element. So you regard it as what? A single thing set. Okay. Now moving on. While finite, or we'll be treating finite and infinite sets as well. Finite and what? Infinite sets. Now for finite sets, as the name implies, it is finite. Okay, meaning it is definite. Okay, that is a set that the counting of the elements will surely come to an end. That is a finite set. They said that the counting of the elements of the points will come to an end. We say it is a finite set. Okay, so to me now, I do regard finite sets as a countable set, a set that you can count the what? The elements. So it is called what? A finite set. But then if counting of the what? Elements will not come to an end, then you say it is what? Infinite. Okay, if counting of the elements will not come to an end, you say what? It is what? Infinite. So that is for what? Finite and infinite. So a good example is you having a is a set of x such that a is an element of natural number, x such that x is an element of natural number, and x is even and also less than um, or equals to 6. So I can put this one as 2 multiplied by n also. Okay, so we'll then list the elements out, and less than or equals to 6. So 2, 4, and 6. Now counting the elements here, 1, 2, 3. You can see the counting comes to an end. Okay, that's a finite set. Okay, now infinite sets. Example of infinite sets is saying set of all prime numbers. Yes, set of all prime numbers is infinite. Before I leave here, I can say set is on earth, human beings on earth. Or in the world. Okay, uh, drop of water, drop of water in a glass cup. The way to, okay, so it is finite. But then for infinite sets, we'll then be talking of for infinite we can say set of prime numbers, okay, you can say natural numbers, you continue and you will not stop, okay. Natural number is from what? 1, 2, 3, and it continues that way, okay. C, set of integers, both positive integer and what? Negative integer. It starts from a value that we don't know, okay. Then move on to jump into -2, -1, 0, 1, 2, 3, and it continues that way too, okay. That's for integer. The same thing for even numbers, the same thing for odd numbers, and so on. Those ones, the sets are infinite. They are infinite sets, okay. So each of natural, set of integer, set of rational numbers, set of irrational numbers, uh, set of whole numbers, set of real numbers in general, they are all infinite. Huh? They are all what? Infinite. That's what infinite sets. Moving on to another type of sets. Moving on to another type, we're looking at equal sets. So we want to difference between I believe you can hear me now. Please, you can hear me, let me know. Let me know if you can hear me. Let me know if you can hear me. You can just signify if you can hear me. I got to know that there is a glitch in. You can hear me now. Please let me know. If you can hear me, please signify so I can continue. If you can hear me, please signify. Please, if you can hear me, let me know. I think I have someone here. If you can hear me, please. You can just comment. Just say I, so I'll know you can hear me. Okay, moving on. Moving on. I was explaining proper subsets. So I said, having known that a subset eh, is a set whose every element is in the superset. Okay, that's the subset. I told you the way we do write it. That's the way we denote it. But then for proper subsets, okay, A will not be equals to B. All other subsets, every subset are proper subsets of a set. The only one that is what improper is the set itself. So meaning A, B, C is a proper subset. This is a proper subset. But subset will be like this. Okay? A is a subset of B. Let's say we have C. We have C to be A, B, C, D, E. And we have D to be A, B, C, E, D, G, F. Okay? A, okay, and E to be this. Now, A is a subset of B and is also a proper is a subset of B and is also a proper subset of B, because every of the element here would have them here. Like every of the element here would have here. These two sets are not what? They are not equal. Okay, so it is a proper subset. Okay, look at C, then look at B. You notice we have everything here though, but these two sets are not equal. So it is a subset and it is also what? A proper subset of B, because the two sets are not equal. Do you get that now? That is how to know if it is proper or if it is not what? Proper. Now look at D. Hmm? D is a subset of B. Every element here will have them here. And at the same time, D is equals to B. Since D is equals to B, then D is not a proper subset of B because they are equal. Okay? Another one is the E we have there. E is a subset of B and is also what? A proper subset of B. Why is it a proper subset? Because it is not equal to B. But at the point in time, it is what? A proper subset. Then it is at the point in time they are equal. Then it is not what? A proper subset. It is improper. So here now we say this D is improper subset of B. Why? Because they are equal. Okay, D and B are equal, so they are what? Improper subset of one another. So a set is an improper subset of itself, but it is a subset of itself. Another thing you need to know again is that empty set is a subset and is even a proper subset of all sets of any set. Empty set, that is void set or you say null set, is a subset or specifically a proper subset of any set. Okay, so that is the explanation on what? On proper subset and improper subset. Again, I say a proper subset, to get it, the sets must not be equal. If they are equal, then it is improper, it is not more proper. But then if the element in A, everything there you can find it in what? In B. Given that they are not equal, it is what? A proper subset. Okay, so all proper subsets are subsets of a set. Are we together now? But not all subsets are proper subsets. Okay, let me write that down. All proper subsets are subsets of a set, but not all subsets are proper subsets of a set. And the only subset that is not what? A proper subset is the set itself. Okay, is the set itself. So you should know that subsets is classified into what? Proper subsets and what? Improper. The improper subset is the set itself. The set itself. Okay, so that is explanation on that. So some points you should note. Another point you should note again is that I said it earlier that every set is a subset of itself, but not a proper subset. Note, every set is a subset, not proper subset. Subset of itself. I said also that empty set is a subset, also a proper subset, of itself, of any set, okay. We then say all sets every set, okay, all sets are proper subsets of the universal set. So that will take us to universal sets. So what's the universal set? That's the mother of all sets. You know, as the word implies, universe. Okay, everything in the world is inside the universe, is in the universe. Okay, so every other set is under the universe. We are under the umbrella of the what? Universe. Okay, so all sets are proper subsets of the universe. So you know what proper subset is now. That is, it must not be equal to the universe for it to be proper. Okay, so you should note that every set is a subset. No, not proper. That is, it is improper. Okay, every set is a subset of itself. Empty set is a subset of any set. That is a proper subset. And all sets are proper subsets of the universal set. Huh? Note, the universal set is the mother of all sets. Okay. Now we'll be looking at the number of subsets that a set will possibly have. The number of subsets that a set will possibly have. Okay. Okay, let's say we have set A to be 0, 1, 2. Okay, let's just stop there. So what are the proper subsets? First of all, the proper subsets. Remember, I told you proper subsets, it will not include the set itself. Okay, the proper subsets, I'll talk of the empty set. That's the first proper subset. Then I'll take each element 1, 1 as a single thing. Okay, and I'll take combination of 2, 2, 2 as 0, 1, 0, 2 and 1, 2. That's the combination. Two combinations. Then if it is 3, 3, we'll say 0, 1, 2. Okay. Now for this one here, you can even use combination. For those people that understand combination, you know I'm not taking anything, it is empty. So how many elements I have here? 3. Abi now? That will be 3 combination 0. I'm not taking anything. 3 combination 0, you should know that n combination 0 is what? 1. Okay, so this one here is 1. So how many do I have here? It is just 1. Now this one I'm taking 1, 1. That will be what? This one I'm taking 1, 1. That will be 3 combination 1. Okay, I should know that n combination 1 is n. So 3 combination 1 will be what? 3. Just like you having 10 combination 1, it will be what? 10. 100 combination 1, it will be what? 100. Okay, so 3 combination 1 is 3. That means if I'm taking it 1, 1, okay, I will have 3 single thing sets, subsets. Okay, The next one is if I'm taking it 2 2. Now that will also be, I know I have 3, but then if I using combination tricks, so it will be 3 combination 2. You should also know if this one here is one more than, if this one here is one more than, one less than this. Probably you have this one to be n, and you have this one to be n minus 1, or you have this one to be n plus 1, and you have this one to be n minus 1, or n rather. So if this one here is one more than this, the value is what? Is n. So if you have 4 combination 3, that what? 4. Do you get that? So if you have 15 combination 4, that what? That's 15. If you have 100 combination 99, that will be what? 100. Okay, that is for that, about that. So since we notice that this one is just one less than this 2 is one less than this, then our answer will be what? The 3 up here. Okay, the 3 up there. So you notice that's 3, and for this one here, that will be 3 combination 3, because we're taking the 3 elements at once. Okay, so that will be 3 combination 3, and you know that n combination n will be 1 rather. So let me help you write everything out. N combination 0 is 1. Okay, n combination 1 is n. Okay, the next one again is n combination n minus 1. That's also n, and I said n combination n will be what? 1. So if you add this, n combination 0 is 1, n combination n is 1. The value combination, the same value is 1. So the value combination 1 will be n, that is the value. The value combination 1 less of the value is to be what? The value, that is n. Okay, so this one here. Okay, I'm sorry for the break, for the disconnection. So what here to be 1, this to be 3, this 3, and this 1. So all together we have that should be 8. 8. Sorry, this one is not a proper subset. It's not part of the proper subset, because you notice that this one is equal to the set. So this one here is improper. Okay, so for the proper, let's start with the proper first. The proper subsets will have 1 plus 3 plus 3, and that will be what? That's 7. And improper, the improper subsets are, that will be the 7 plus 1, and that's what? 8. So instead of doing this, there's a general formula. For the subset generally, for the proper subset, it is 1 plus 3 plus 3 plus 7. And for the subset generally, that is the proper subset plus the what? The improper subset. That will be the 7 plus 1. This 7 here represents the proper subset, and the 1 here represents the what? The improper subset. I'll have that to be what? To be 8. Okay, so instead of going through all this process, you can just say, to get your subsets, the number of subsets that a set could possibly have is given by number of subsets that a set could possibly have, number of subsets of a set is given by 2 raised to the power of n, where n is the number of elements, or say number of points of the set. The number of points. I told you what point is. Point is the element. Okay, so look at this here now. We have 3 points. So
Okay. Looking back to this, I said proper subsets. I don't know the stuff disconnected. Okay, so for proper subsets, okay, well, this, and this to be the proper subset. Remember, I said it earlier that improper subsets will be the set itself. So this one is the set already. Okay, so that one is improper. So this, and this are the proper subsets. So the number of proper subsets that we have are for this set to be 1 plus 3 plus 3, and that's 7. And for the number of subsets in general, that's this one, 3, 3, and this one all together, that will be 8. That means the possible number of proper subsets plus the number of the improper subset. This is the proper subset and this is the improper. Adding them together, that will give us the number of subset that a set will have. So in short, instead of going through all this process, you can just say it is just 2 raised to the power of n. 2 raised to the power of n to get the number of subsets of a set. Okay? For this question now, it will be 2 raised to the power 3, where n is the number of points, that is the number of elements. We have 3 elements here. That's 2 raised to the power 3, which will be 8. But then if it is the proper subset that they ask you to find, remember the proper subset is one less than the what? The subset itself. So just subtract 1 to get what? The proper number of proper subset. So for this one, the number of proper subset for this question here to be 2 raised to 3 minus 1. 2 raised to 3 is 8. 8 minus 1 is what? 7. Okay? So thank you very much for watching. So we can catch up later to continue the class on set theory. Thank you very much. Subscribe to get more, to enjoy more of this.